Hey everybody, this is Jed Clampett, and this is the first thing you know. This will be a lesson on solving linear systems by the graphing method. So let's begin. Okay, I'm going to pass out some graph paper to you guys, but for now, you guys, if you don't have graph paper, no deal. I mean, no big deal. You just need a straight edge, okay? So get something like a ruler or the side of a card, something you can draw a nice straight line with. So here's solving each system by the graphing, okay? So here's two equations. So 5x plus y equals 0 and 5x plus y equals 10. Okay, these are both lines, you guys. So we're going to graph these lines. We're familiar with graphing lines from chapters 4 and 5 and 6. Um, okay, so I'm going to graph the first line in red, and I'm going to graph the second line in blue. Okay, now can you see, I didn't do this for us, but can you see on this red line, if I went plus 5x over here and plus 5x over here, can you see me getting this equation right here? I just added 5x to both sides. Okay, so now I'm going to go ahead and graph this 0 on the y-axis right here. This is my y-axis. So I'm going to put a point right there. Okay, I'm going to graph that 0. Okay, so I did a black point right there to show it that that's this 0 right there. Then I'm going to use this 5x, which is 5 over 1, you guys. That 5 over 1 means I'm going to go from here up 5 to the right 1. Up 5 to the right 1, and I made another point. Okay, so I need 2 points. There's my line right there. And if I connect them up, there they are. Okay, so now we're going to graph that blue line. So what I'm going to do is do the same method. This time I'm going to subtract this 5x and put it over here with this 10. So that's going to get me y equals negative 5x plus 10. All right, so this is my plus 10. I got to go on this y-axis plus 10. So what I have to do is extend this line up a little bit further. So let me extend that up a little bit further. And I'm going to go ahead and put that plus 10 right there. See that way up there? And then now my slope is negative 5 over 1. So I'm going to go down 5 and then to the right 1. So when I go down 5 and to the right 1, it takes me right through there. And my goal is to find out where these two lines intersect. And obviously they intersect right there. And you need to know the ordered pairs of that. So it went from the origin, went over 1, up 5, so they're intersecting. They both share the same point, 1 comma 5. So that's the solution, where they intersect is at 1 comma 5. That's the answer. All right, let's try another one. Okay, x minus y equals 5. This time I'm not going to solve for y. I'm going to use the intercept method. And then 3x plus y equals 3. Okay, I'm going to do them in color. So I'll do the top one in red and the bottom one in blue. Okay, again, so here I'm going to let x equals 0. And then when x equals 0, pretend like that x isn't there. And you have negative y equals 5. So y must be negative 5. So there it is right there, 0, negative 5, right down there. Okay, now when y is 0, then this negative y goes away and I'm left with x equals 5. So x equals 5 is going to be way over here. Okay, I'm going to go ahead and connect those lines right there. There's that line right there. Okay, I'm going to do the same thing, the 0 actions, and I think I did it in one step. I graphed them and everything. So when x equals 0, y is going to equal 3, and then y equals 0, 3x equals 3, so x equals 1. So I get, okay, so when x equals 0, y equals 3, and when y equals 0, x equals 1. So there's 0, 3 right here, and then here's 1, 0. Go ahead and connect those guys. And then where they intersect looks like right about here. So to me it looks like it's over 2, down 3. Over 2, down 3. That would be the answer right there. All right. Then you're going to have some that says, tell whether the ordered pair is a solution to the system of equations. So here's an ordered pair right here. And is this ordered pair, this x equals 3, y equals 2, will it make this equation true and this equation at the same time? If it is, then yes, it's a solution to the system. If it's not to either one of them, then it's not a solution. It has to be a solution to both of them. So I'm going to substitute in x equals 3 and y equals 2 into both equations. So here we go. X equals 3, so I have x equals 3 right here. That's what this is. Plus 2 times y, but y equals 2. And then this equation says it equals 7. On this one, 3 times x, remember 3 times x is 3, minus 2 times 2. So 2 times 2 is 4. Is 3 plus 4 equal to 7? Yes. Okay, and is 3 times 3, which is 9, minus 4 equal to this 5? Yes, so they check off on both cases right there. So yes, it is a solution. All right, one more of these guys. Okay, so is this ordered pair, negative 3, 3, a solution to this equation and at the same time to this equation. So I'm going to just check on this equation first, because if it's no, I'm done. The answer is no. It's not a solution to the whole system of equations. So I'm going to substitute in x equals -3 and y equals +3 into this equation. And if it's yes, then I'll try this equation. But if it's no, I'm gonna stop, because it won't be a solution. Okay? And it turns out 2 times -3 is -6. 3 times 3 is 9. -6 plus 9 does not equal 12. So since it's not a solution to that one, then it's not going to be a solution to that system of equations.